Hello and welcome back to yet another session of Target JEE Advanced brought to you by the team here at Byju's. In today's session, we are going to look at a very important chapter, definite integration. Now, this chapter is a very crucial chapter when it comes to your JEE main and advanced examinations because inevitably every year many questions come from this chapter in the examination. Because this chapter is so important and huge number of questions come from here in the examination, we've decided to split this chapter into two. We will look at definite integrals in one particular chapter and we will look at the application of definite integrals, which is area under the curves, in yet another session. So we've divided this into two sessions so that we can focus a lot into this particular chapter and we can solve wide varieties of questions in this particular session. So in today's session, we will look at definite integrals and we will do a very quick analysis of definite integrals from the examination point of view. Let's have a look at how important is this chapter from the JEE main examination point of view. Well, in the past so many years, in every session, one question has definitely been there from definite integrals in the JEE main examination. Starting 2013 until the recently concluded examination, every session has seen one question, and the most important section has been properties of definite integrals. 2013, 14, 15, all these years there were questions on definite properties of definite integrals. Starting 2016 until the recently concluded examination, the question paper setters have tried to mix and match concepts. Properties have been asked, but sometimes questions have come from Riemann Sum, that was in 2016. There have been questions on Newton-Leibniz theorem also, that was in 2018. But mostly, if you go through properties of definite integrals, you're good to go when it comes to the JEE main examination. But that's not the case with JEE advanced examination, because JEE advanced examination is going to be difficult. The questions which come from definite integrals is really going to be tricky questions, and different concepts are covered in definite integrals. So let's have a look at the past few years. 2018, there were two questions from definite integrals. One was a multi-select type of questions, multiple correct answer questions. That was from the Leibniz theorem or the Newton-Leibniz theorem. Then there was a numerical or an integer type of question, which was based on Riemann sum. So this was 2018 for you. Then came 2017. There were four questions. 2017, Newton-Leibniz theorem was tested multiple times. Three questions from Newton-Leibniz theorem. Multiple correct answer kind of question, a single correct answer kind of question, an integer type of question. Everything from Newton-Leibniz theorem. And based on properties of definite integrals, there was a multiple correct answer kind of questions. So four questions from definite integrals in 2017. 2016 also saw three questions, an integer type of question from Newton-Leibniz, a multiple correct answer kind of question from Riemann sum, and a single correct answer type of question from properties of definite integrals. This was 2016 for you. Then comes the mega year 2015, where there were five direct questions from definite integrals. One passage type of question. Well, the passage had questions which were based on multiple concepts of calculus. One question was directly from definite integrals. It was a simple definite integral question, not many usage of properties or the advanced topics such as Newton-Leibniz theorem or the Riemann sum. There was one question from there. There were two integer type of question. One was based on Newton-Leibniz theorem, and there was also some amount of limits involved in that particular question, and one was a properties type of question. Then there were a couple of multiple correct answer kind of question. One was based on the maximum and minimum value of definite integrals. That was not a routine question, again a different variant of a definite integral type of question. And then the second multiple correct answer kind of question was based on properties of definite integrals. So these were the five questions which came in the year 2015 from definite integrals. 2014 was also a year which saw four questions come from definite integrals. Well, in fact, totally there would have been six questions, because there was a passage which had two questions, and these were based on limits and also on properties of definite integrals. And then there was a match the following type of questions, out of which two were definite integral types of question. There was an integer type of question, which was basically a very simple definite integral question, but still a question from definite integrals. And finally, a single correct answer kind of question, which was based on properties. Again, a year where a lot of questions came from definite integrals. 2013 was a year when there were minimum number of questions from definite integrals, just one single correct answer question which is based on properties. But in the past 5 years, you see there have been huge number of questions from definite integrals, and the questions are not easy. They tend to be very tricky and test your understanding of definite integrals to a very, very thorough level. So make sure that your preparation of definite integrals is very strong if you aim to score high in the JEE main and advanced examination, because inevitably huge number of questions come from this particular chapter. I will quickly take you through the concepts which are important from this chapter before we look at some really tricky and interesting questions. So the chapter on definite integrals is a continuation of indefinite integrals. So in indefinite integrals, you did not look at the limits of integration. So your answer would always end up with a constant of integration. But when it comes to definite integrals, you always have to evaluate the answer that you get by substituting the value of the endpoints of your domain. So that's the only difference between definite integrals and indefinite integrals conceptually. And then there is an application of definite integrals, which is nothing but the area under a curve. So if you have a curve, then the definite integral of that particular curve from the limits a to b gives the area bound between the curve and the x-axis. So that's an application of definite integrals. But because of these limits, a lot of interesting things happen to definite integrals, and that is explored in the concept of properties of definite integrals, a very crucial concept. Number of questions come from this concept in the examination. There are plenty of properties, and it's worth knowing all of these properties. The best way to actually learn these properties is to solve number of questions based on these properties. Well, initially we have these simple properties, a property of dummy variable, property of interchanging the limits, a property of splitting the limits, and then of course you have this interesting property which is a definite integral of a to b f of x dx is nothing but definite integral of a to b f of a plus b minus x dx. So all these are very interesting properties of definite integrals. Then of course you have more properties, properties which deal with the limits of the kind 0 to 2a. Well, you have three properties which are based on limit from 0 to 2a f of x dx. And finally, you have this way of converting a limit from the interval a to b to 0 to 1. So integral from a to b f of x dx is b minus a, integral from 0 to 1 f of b minus a x plus a dx. So this is another very interesting way of converting the limits of your definite integral. Then this very interesting property of odd or even functions. If you have integral from negative a to a f of x dx, that becomes 0 if your function is odd, and it becomes 2 times integral from 0 to a f of x dx if your function is even. So this is the beautiful property of a definite integral for odd and even functions. And then you have a lot of properties for periodic functions. You know that there are plenty of periodic functions that you learn about in your 11th and 12th standard. So if all these functions appear, and then you can play with their periodicity. So integral from 0 to nt f of x dx is nothing but n times integral from 0 to t f of x dx, but t is the periodicity of that particular function, the period of your periodic function. Then there are more interesting properties. So there are plenty of properties, and knowing all these properties and playing with them will actually make you very, very thoroughly confident with these particular properties, and any question that comes in the examination can then be tackled with ease using all these properties. Then we move on to a very important theorem from the JEE advanced examination point of view, and that is the Leibniz rule, or sometimes it's called the Newton-Leibniz theorem, because Newton and Leibniz historically are supposed to have come up with these two theorems independently. So this particular theorem is a very interesting theorem. It connects differentiation to integration. So the differential of the integral of f of t dt, where the limits are functions of x, u of x and v of x, that's nothing but f of v of x multiplied by the derivative of v of x with respect to x minus f of u of x multiplied by the derivative of u of x with respect to x. So this is connecting definite integrals to differentiation. So that's a very important theorem, and multiple questions have come in the past year from this particular theorem, the Newton-Leibniz theorem or the Newton-Leibniz rule. It's a very interesting theorem connecting definite integrals to differentiation. Finally, there is a concept which connects limits to definite integrals, and that is the concept of Riemann sum. So how do you convert a limit of n tending to infinity if it was this particular form to a definite integral? That's what Riemann sum talks about, and Riemann sum is also a very interesting and important theorem, and this finds a lot of application in the examination. So these are broadly the concepts that are important from definite integrals in the examination, and now we will look at these particular concepts in the questions and solve some interesting questions. We will start with Riemann sum, and then we will move on to other concepts such as the Leibniz rule and properties of definite integrals. The first question is a question which is based on Riemann sum. So let's have a look at this question. So in this question, we have to find the value of limit as n tends to infinity of 1 by n square sine square pi by 4n plus sine square 2 pi by 4n, that's multiplied by 2, plus 3 sine square 3 pi by 4n, so on up to n sine square n pi by 4n. So you have to find the value of this. So in Riemann sum, well, that's a concept that connects limits to definite integrals. So you have something like limit of n tending to infinity 1 by n, a summation of r running from 0 to n of some function of r by n. Then this can be converted into an integral. This is nothing but a definite integral from 0 to 1. Now, wherever there is r by n, you're going to replace it with x. So you're going to get the function of x dx. So this is the concept of Riemann sum, and this is what we are going to use in this particular question. So I need limit n tending to infinity 1 by n. But in the question statement, we have 1 by n square. So I'm going to take one of those n's inside and rewrite it as limit n tending to infinity of 1 by n. And then you have 1 by n sine square pi by 4n plus 2 by n sine square 2 pi by 4n plus you would have the next term, which would be 3 by n sine square 3 pi by 4n, so on all the way up till n by n sine square n pi by 4n. Now this we can rewrite in a form that will give us something that can be converted into a definite integral using Riemann sum. So this can be written as limit n tending to infinity of 1 by n summation of r running from if you let's look at what is inside the summation first. So you will have r by n sine square pi by 4n times r. So this is what is r? R is nothing but it is running from 1 to n. But notice when you put r equal to 0, you will get 0 times sine square pi by 4n into 0, which is nothing but 0. So you can actually add a 0 to this without changing the summation at all, and rewrite this as limit n tending to infinity 1 by n summation r running from 0 to n r by n sine square of pi by 4 r by n. So this entire thing which is inside the summation here, that's a function of r by n, and we have limit n tending to infinity 1 by n summation r running from 0 to n, a function of r by n. So we can rewrite it as a Riemann sum. So this will become nothing but integral from 0 to 1. Well, there was an r by n, so r by n becomes x, and then you have sine square pi by 4 r by n, that becomes pi by 4 x. So this is the definite integral that you have to compute. Now this is not a very difficult integration question. In fact, you have to use integration by parts to solve this question. From here on, it's just definite integrals, no more Riemann sum. And I don't think you need any properties of definite integral in this particular question. What I'm going to do is first convert sine square in terms of cos 2 theta. So I can write this as a 0 to 1 integral x times 1 minus cos 2 theta. Theta here is pi x by 4. So cos pi x by 2 all divided by 2 dx. So I take the 1 by 2 all common out and then open the bracket to get 1 by 2 integral of x. Well, integral of x is nothing but x square by 2 and limits 0 to 1 minus I have the integral of x cos pi x by 2. So I have this integral now, and that is where I need to make use of integration by parts. I will consider x as my first function, cos pi x by 2 as my second function, and integrate it by parts. So if I integrate this by parts, I'm going to get x times integral of cos is sine pi x by 2 all divided by pi by 2 minus the integral from 0 to 1. The differential of x is 1. Integral of cos is nothing but sine pi x by 2 divided by pi by 2 and that is dx here. So now this has to be evaluated between 0 and 1. I just need to integrate the last bit here. So minus integral of sine pi x by 2. So I'm going to get a plus here and I'm going to get a cos pi x by 2 divided by pi by 2 the whole square. So now just evaluate everything from your using your limits. Of course, you have the half outside, so you have 1/2 of x square by 2 evaluated between 1 and 0 gives you 1/2. Then you have the minus and x sine pi x by 2 divided by pi by 2. When you put in the value 1, you get 1 times sine pi by 2. That's 1 divided by pi 2 by pi by 2. So that gives you a value of 2 by pi. When you put the value 0, that vanishes completely. Then you have plus, well, cos 1. When you put in the value of 1, you're going to get cos of 1 times pi by 2. That's going to be cos pi by 2 divided by pi by 2 the whole square. That will vanish out completely to give you a 0. So you have to actually consider 0 minus. When you put in the value of 0, you get cos 0. Cos 0 is 1. So you actually have 2 by pi the whole square there. So this was a pretty routine, straightforward question. If you finally simplify this, you're going to end up with an answer which is going to be 1 by 4 minus 1 by pi plus 2 by pi square. So that is the correct answer to this question. The definite integral bit of it is not really complicated. There's just integration by parts that you need to make use of in this case. The real tricky bit was converting that limit into a Riemann sum and then converting it into a definite integral. That was a tricky bit in this particular question. Now in this question, we've been asked to find the value of limit extending to 0 2 times the integral from 1 to cos x of sine inverse of under root of 1 minus t square dt all divided by 2x minus sine 2x. So how do you approach this question? It's a limit question. It has an integral in the definition of the limit function. So let's try and see how to solve this using the ideas that we've learned in the chapter on limits. First of all, if you plug in the value of x equal to 0, what will happen? Well, if you plug in the value of x is equal to 0, cos x, well, this will become something which is cos 0. Cos 0 is 1. So you have an integral running from 1 to 1. That's going to be 0 irrespective of whatever is inside the integral, because your limits of the integral are from a to a itself. So that's going to be 0. And if you put x is equal to 0 in the denominator, you're going to get a 0 here, and sine 0 is also 0. So you'll have a form 0 by 0. So you can use the L'Hopital's theorem. So if you use the L'Hopital's theorem, you have to differentiate the numerator and the denominator. So then you're going to get limit extending to 0 2 times. Now you have to differentiate integral from 1 to cos x sine inverse of 1 minus t square dt. Now the differential of this is nothing but sine inverse of under root of 1 minus cos square x into the differential of cos x, which is nothing but minus sine x. Well, that's the differential of your numerator, and this is going to be divided by 2 minus, where the differential of sine 2x is going to be 2 cos 2x. Now we can actually try and simplify to the expression in the numerator, where there's a 2 which is common there. I'm going to remove all the 2's from there, and my numerator now will become sine inverse of under root of 1 minus cos square x is mod sine x. Do not forget the mod there. Under root of 1 minus cos square x is mod sine x. This is multiplied by, of course, minus sine x, and everything is divided by 1 minus cos 2x. 1 minus cos 2x is nothing but 2 sine square x. Again, a lot of simplification is possible here. Now, what is sine inverse of mod sine x? Remember, x is a value which is very close to 0. So if x is a value which is very close to 0, sine x is also going to be a value which is going to be very close to 0, slightly positive, slightly negative. It will be slightly more than 0 and slightly less than 0. Now, mod of sine x is always going to be slightly more than 0. So it is going to take a value which is equal to sine x, the positive value of sine x. Even if x is negative, you're going to get the mod of sine x to be a very small positive value. So sine inverse of mod sine x can be written to be equal to mod x, because x is very close to 0. So this can be written as mod x divided by 2 sine x. Now let's try and find out if the limit of this exists, or if it exists, then what is its value. So limit extending to 0 of mod x, negative mod x divided by 2 sine x. The left hand limit is going to be limit extending to 0 minus, that's from the negative side, we're going to approach towards 0, of minus of mod x. Now if x is negative, mod x is going to be minus x divided by 2 sine x. Well, this is going to be equal to 1/2, because sine x by x is equal to 1 as x approaches 0. So this is going to be equal to half. What about the right hand limit? The right hand limit is limit extending to 0 plus minus of, now because x is a positive number and is approaching to 0 from the positive side, mod x will be just x divided by 2 sine x. Again, sine x by x as x goes to 0 is 1. So this is equal to -1/2. Clearly, the left hand side and the right hand limit are not equal. So since the left hand limit and the right hand limit are not equal, we can conveniently say that the limit does not exist. A very interesting question, and the key to this question is the fact that under root of 1 minus x square cos square x is not sine x but mod of sine x, and sine inverse of mod sine x, because x is a very small number, it's very close to 0, can be written as mod x. So that's the key bit in this question. If you get that right, you'll get the question correct. In the next question, we've been told that f of x the whole square is integral from 0 to x f of t times 4 divided by sine 2t minus 4 sine square t plus 4 dt. Further, f of 0 has been told to be equal to 0. We've been given that f is a continuous function and also that f is not a constant function. The objective in this question is to find out the values of f at 3 pi by 4, at pi by 4 and at pi by 2. It's a multiple correct answer kind of question. So we'll have to check for all the options. So before moving into finding the value of f, let's first determine what f is, because we know f of x the whole square and not f of x. So how do you go about this question? Before that, let's simplify this expression of f of x the whole square, because I see a complicated expression in the denominator, the trigonometric expression. So let's try and simplify this. Now this is 4 times 1 minus sine square t, which is nothing but 4 cos square t. Now you have a sine 2t and a 4 cos square t. What I'm going to write is, I'm going to write cos square t as 1 upon secant square. So this can be written as 4 by secant square t. The reason why I do that is because I can write sine 2t in terms of tan squares or tan t's and tan square t's. So my sine 2t, that's going to be equal to 2 tan t divided by 1 plus tan square t. Tan square t is nothing but secant square t. So in this way, I can get a common denominator of secant square t. So that's how I'm going to solve this question. So my f of x the whole square, well, f of x the whole square, that's going to be equal to integral from 0 to x f of t 4 divided by 2 tan t by secant square t. Then of course there's a plus 4 by secant square t. Now the common denominator of secant square t can come into the numerator, and what I will have in the denominator is 2 tan t plus 4. I can cancel out one of the 2's from all of these expressions to get the expression for f of x the whole square as nothing but integral from 0 to x f of t into 2 secant square t divided by 2 plus tan t dt. Now we need the expression for f of x and not f of x the whole square. Taking an under root is not a solution to this, because then you still have to compute the value of the definite integral. But what I will do is I will take a derivative of both the left hand side and the right hand side, and using that what I get is 2 f of x into f dash of x to be equal to, well, the derivative of the right hand side is simply whatever is there inside the integral with all the t's changed to x. It's f of x into 2 secant square x divided by 2 plus tan x. The differential of x is 1, so you don't have to multiply by 1 because that is understood. So now my expression has become really simple. Further, it's been told that f is not a constant function, so I can actually cancel out the f of x from both the sides, and I can cancel out this 2 as well. So I actually have f dash of x to be equal to secant square x divided by 2 plus tan x. Now you'll have to actually integrate this expression to arrive at f of x. Integrating this is going to be simple because you're going to take 2 plus tan x as your new variable t. Then your secant square x dx, this entire thing here will be equal to dt. Do not forget the dx here because you are integrating. So you have dt upon t to be integrated. That is nothing but log of mod t. So you're going to get the value of f of x to be equal to log of mod 2 plus tan x plus the constant of integration. So we started with a definite integration question, but then we converted into an indefinite integral, and we have that constant of integration. We've been told that f of 0 is actually equal to 0. So if you're going to put the value of f of x to be 0 with x as 0, so then you get the value of c to be equal to minus log of 2. So the value of my f of x is nothing but log of a mod. This is going to be 2 plus tan x minus a log of 2. So this is the value of f of x, and from here on the question is very straightforward. So what is f of pi by 4? Well, f of pi by 4, you plug in the value of x equal to pi by 4 in that expression. You have tan pi by 4. Tan pi by 4 is 1. So you get log 3 minus log 2, which is nothing but log of 3 by 2. Well, f of pi by 4 equal to 3 by 2 is one of the options given. That's the correct answer. That's one of the correct answers to this question. F of pi by 4 equal to some other value which is not equal to 3 by 2 will not be a correct answer to this question. Then what is f of pi by 2? Well, pi by 2, at pi by 2, what happens to tan x? Tan x goes to infinity, positive infinity, log of positive infinity. Well, that's definitely not equal to 2 as given in the question. So that option which says f of pi by 2 equal to 2 is wrong. And finally, f of 3 pi by 4. Well, 3 pi by 4, tan 3 pi by 4 is equal to minus 1. So this will be log of 2 minus 1, which is equal to log 1, that's 0, minus log 2. So the correct answer to f of 3 pi by 4 is nothing but log of 1 by 2. That's the correct answer to this particular question. Now, in this particular question, we have a function f of x, which is a determinant of this particular matrix here. The objective in this question is to find the value of integral from negative pi by 2 to pi by 2 of f of x plus f double dash of x divided by 2. Wow, that seems to be quite a question because f of x is a determinant. So in order to find f double dash, you have to differentiate the determinant 2 times. That seems to be a Herculean task. And if you're going to solve it this way, you will never be able to solve this question. Probably it'll take you an hour and still you will go wrong in this particular question. So that means there is some other way of solving this question, and that is where properties of definite integrals will come into picture. So integral from negative a to a f of x dx is equal to 2 times integral 0 to a f of x dx if f is an even function, and that's equal to the integral is equal to 0 if f is an odd function. So let's try and find out what happens to f. Is it an even function or an odd function? So in order to determine that, let's try and find out what is f of minus x. So f of minus x, that's going to be equal to the determinant of 2, wherever there's an x, you're going to put a minus. So there's going to be minus 2x sine square of minus x by 2, but it's sine square. So that's really not going to change if it's an x or an minus x. So you have sine square minus x by 2. Tan x will become tan of minus x plus minus x the whole cube. And finally, you have minus x plus sine of minus x as the last term in that particular row. The second row, that's going to be e power minus x square. That's going to be just x square. A secant of minus x, well, secant of minus x is secant x because secant is an even function. 2 will be unaffected by whether you have an x or a minus x. Cos is again an even function, so cos minus x will be cos x. X power 4 is also an even function. So you're going to get minus x all raised to 4, which is going to be just x power 4, and then a 1 here. So let's analyze what happens in the first row here. In the first row, you have minus 2x times sine square minus x by 2. Sine square minus x by 2 is an even function, but because there is a minus 2x, well, you can take the minus common out from there and write it as 2x sine square minus x by 2. Tan minus x is nothing but minus tan x plus minus x the whole cube is nothing but minus x cube. So you can take a minus from there as well. And the last term will be minus of x plus sine x because sine minus x is minus sine x. So you have a minus in all the terms of the first row. So you can take all the minus out. So if you take the minus out from there, you are going to get the fact that your f of minus x is nothing but minus f of x. This means that my f is an odd function. So if f is an odd function, what do we know about f dash? If f is an odd function, f dash is an even function, and f double dash will be again an odd function. So in the question statement, we have to find integral from negative pi by 2 to pi by 2 of f of x plus f double dash of x divided by 2 dx. F is an odd function. F double dash is also an odd function. So this integral will be equal to 0. You don't have to differentiate your determinant. You don't have to integrate determinants. This question is solely based on properties of definite integrals. Now in this question, the objective is to find the integral from 0 to pi of 5x cube cos power 6x sin x dx divided by pi cube minus 3 pi square x plus 3 pi x square. Now this seems like a monstrous question, doesn't it? You have a product of 3 functions in the numerator and a complex looking expression in the denominator. So how do you go forward and solve this particular question? Well, using properties of definite integrals, this question is actually not a very difficult question. So in the denominator, you have pi cube, 3 times pi square x with a minus sign plus 3 times pi x square. If I subtract an x cube from here, this becomes nothing but pi minus x the whole cube. and then of course I have to add the x cube. So I'm going to change my denominator and write it as pi minus x the whole cube plus x cube. So 5x cube cos to the power 6x sin x divided by pi minus x the whole cube plus x cube dx. This is my restated question problem statement. Now the reason why I did this is because in the numerator you have x cube and the limits are from 0 to pi. So you use the property and rewrite the numerator as nothing but, so wherever you have x, you're going to write it as 0 plus pi minus x. That's going to be my property. So if I have integral a to b f of x dx, this is nothing but integral from a to b f of a plus b minus x dx. So I'm going to use this property here and rewrite this entire thing as integral 0 to pi 5 times pi minus x the whole cube cos of pi minus x is minus cos x, but there's a sixth power, so that's going to remain as cos x itself. Sine of pi minus x is anyways just sine x, so that's not going to change, divided by, now pi minus x the whole cube will become just x cube, but x cube will become pi minus x the whole cube. So this was I, this is also I. So if I add these two things, I get 2I to be equal to integral 0 to pi. Well, cos power 6x, sin x and 5, all of them are common. So I have 5 cos power 6x sin x. And then I have x cube coming from the first term divided by pi minus x the whole cube plus x cube. Well, pi minus x the whole cube plus x cube is there in both the expressions. So that'll be my common denominator. So I have x cube coming from the first term, pi minus x the whole cube coming from the second term. The denominator is nothing but x cube plus pi minus x the whole cube. So these terms are going to cancel out. And my integral now is very simple. I have 2I to be equal to integral 0 to pi 5 times cos to the power 6x into sin x dx. Very simple integration by substitution question now. Sin cos x equal to t, then my sin x dx becomes minus dt. So you have 2I to be equal to negative of integral when x is 0, cos x is 1. And when x is pi, cos x is equal to minus 1, 5 times t power 6 dt. This is the new integral that you have to simplify. Well, the first thing I do is I change the limits. So the limits are going to change from 1 to minus 1 and it's going to change from 1 to minus 1 to minus 1 comma 1, and the negative sign outside will cancel out. So I have 2I to be equal to 5 times t power 7 divided by 7 between minus 1 and 1. So that's going to be equal to 5 times 1 by 7 minus of minus 1 by 7, so plus 1 by 7. So 2I will be equal to 2 times 5 by 7. So that's going to give you the value of I to be equal to 5 by 7. So the correct answer to this question is 5 by 7. Now we have a multiple correct answer kind of question wherein we have to check if the 4 options given are true or false. Okay, so we have to find out which are the true statements out of the 4 statements given. So let's look at the first statement here. It says integral from negative 2 to 1 of e power 2 times the fractional part of x multiplied by e power fractional part of x dx. That is equal to 3 times e power e multiplied by e minus 1. We have to check whether this is correct. So in order to solve this question, we are going to make use of the periodicity of the fractional part of x. The function which is the fractional part of x has a period of 1. So actually this function repeats itself in each subdomain. So from 0 to 1, whatever happens to this function, the same thing happens from 1 to 2, 2 to 3, 3 to 4 and so on. And also in the negative regime, negative 1 to 0, negative 2 to negative 1, everywhere the function actually repeats itself. But in one of these subdomains, that is when x is in 0 to 1, what happens to this function is the fact that the fractional part of x actually becomes equal to x itself in this particular subdomain. In fact, this is true for a subdomain 0 to 1 with 0 included, but for the case of integration, we are going to not consider 0 included as a subdomain. That's really not important. So in this particular subdomain, 0, 1, fractional part of x equal to x. But fractional part of x repeats in every subdomain. So I can actually rewrite my question as 3 times integral 0 to 1 e power 2 times the fractional part of x. Well, in 0 to 1, the fractional part of x is x itself, so I can write it as 2x multiplied by e power x dx. So this is the integral that I need to solve. And the reason why I do this is because of the periodicity of the fractional part of x and the fact that the fractional part of x is equal to x in 0 to 1. So that's the domain that I'm going to consider. Okay, so now how do we solve this question? Well, I'm going to consider e power x as my variable t. Then what happens is e power x dx will becomes dt. So e power x dx is nothing but dt. So my question statement actually is e power x into e power x into e power x dx. So e power x is t, e power x here is t, and this portion here, that will become my dt. So the question now is nothing but 3 times integral t times e power t dt. Well, now the limits of integration has to change because e power x is my t. So when x is 0, my lower limit is going to be 1. And when x is 1, my upper limit is going to be e. So I have to solve this particular integral. Well, integration by parts, that's what we're going to make use of here. So this will be equal to 3 times. Well, t will be my first variable. So keep t as it is, integrate e power t. So that's going to be just e power t in the domain 1 to e. Minus the integral from 1 to e, or the differential of t is 1 and the integral of e power t is e power t, so e power t dt. So that's going to give me 3 times. Well, when we substitute for the limits in the integral that we have computed, we're going to get e into e power e minus 1 into e power 1, that's going to be just an e, minus of integral of e power t is e power t. So e power t evaluated between e1 and e. So that's going to give me an e power e minus an e. So in fact, here there is a plus e and a minus e. These are going to cancel out, which is going to give me 3 times. If I take e power e common out, I get e minus 1, which is exactly what was given in the problem statement. So the first part of this question is actually a true statement. So we're going to mark this. Remember, there are marks for partial correct answers. So if you don't have time, you can actually just leave this and go ahead. You will get partial marks. But of course, we will try and solve everything, right? So now let's look at the second part of this question. So in the second statement, we have a really complex looking integral. Integral from 0 to pi by 4 of tan of x minus greatest integer of x to the power 2019 plus tan of x minus greatest integer of x to the power 2017, and we have to see if this integral is equal to 1 over 2018. Looks like a monstrous question, but believe me, this is actually a very simple question. Because what are my limits of integration? My limits of integration are 0 to pi by 4. Pi by 4 is 3.14 by 4, which is less than 1. So in 0 to pi by 4, the greatest integer of x is always going to be equal to 0. So actually this greatest integer of x can be completely ignored because that is going to be equal to 0. So my integral will change to 0 to pi by 4 tan x to the power 2019 plus tan x to the power 2017 dx. Now this is a very, very simple question and we can easily solve it. What I'll do is I'll take tan power 2017 common out, and then what will I have? I will have tan square x plus 1. Well, tan square x plus 1 is secant square x, right? So if I say tan x as my t, secant square x dx becomes dt. So I have integral of t power 2017 dt. I have to change the limits. Well, when x is 0, tan x is also 0, and when x is pi by 4, tan x is 1. So I get the answer to t power 2018 by 2018 evaluated between 0 and 1. which actually gives me the answer to be equal to 1 over 2018, which is exactly what is given in the options. So the second answer is also true. So you mark the second option also. So options 1 and 2 are both correct so far. Again, if you feel that you've solved this question enough, you can stop here, get partial marks for the answers and move on to another question. But for all of you who enjoy doing definite integrals, you will solve the third and the fourth part as well, because even those are not very difficult. So let's have a look at the third part of this particular question. So in the third part of this question, we have to evaluate the integral from negative pi by 4 to 31 pi by 4 mod of sin x plus cos x dx, and see to it if this value is equal to 8 root 2. So how do we solve this question? Well, this is a very routine trigonometric equation question, because you have sin x plus cos x. So you're going to divide and multiply by root 2. So when you divide and multiply by root 2, the integral is now changed to negative pi by 4 to 31 pi by 4 root 2 times. Well, this is whatever is inside the mod is going to be just sine of x plus pi by 4. Well, that's pretty simple, isn't it? And now we're going to use a dummy variable to simplify our calculations further. X plus pi by 4 is going to be my new variable t, and so dx will be dt. And my integral now changes to root 2 times integral from, well, negative pi by 4 is going to become equal to 0, because my new variable is x plus pi by 4. So when x is negative pi by 4, x plus pi by 4 will be equal to 0. And when x is 31 pi by 4, x plus pi by 4 will be 32 pi by 4, which is nothing but 8 pi. So I have 0 to 8 pi mod of sine t dt. Now, in order to solve this, we're going to make use of the periodicity of mod sine t. A mod sine t is a periodic function with a period of pi. So whatever happens from 0 to pi is going to repeat from pi to 2 pi, from 2 pi to 3 pi, 3 pi to 4 pi, and so on. And so this integral can now be rewritten as 8 times root 2 integral from 0 to pi mod of sine t dt. But what happens to mod sine t in 0 to pi? Well, sine t is positive in 0 to pi, which means my mod sine t is going to be nothing but sine t itself. So the mod sign there is a little superfluous mod that's not needed. So we're going to now simplify this very simple integral and write it as 8 root 2 times negative cos t evaluated between 0 and pi. So that's going to be nothing but negative 8 root 2 cos pi is negative 1 minus of cos 0, which is 1, gives me an answer of 16 root 2. Unfortunately, that is not what is given in option C. Option C is hence false. Options A and B were correct. Option C is false. We have one more option to look at. Let's see what is the nature of that particular option, whether it's true or false. So in option D, we have to evaluate an integral between negative pi by 4 and 31 pi by 4. This time it's the mod of sin x plus the mod of cos x dx, and we have to see if this is equal to 8 times root 2. So now this is actually a more simple question. So if you look at the graph of mod of sin x plus mod of cos x, well, remember, it's a graph worth knowing. So what happens to mod of sin x plus mod of cos x? Well, if you look at this graph is a graph which has a period of pi by 2. So this is a graph which has a period of pi by 2. If you look at what happens from negative pi by 4 to pi by 4, whatever is happening, the same thing is repeating from pi by 4 to in fact 3 pi by 4, and then from 3 pi by 4 to 5 pi by 4, the same thing is repeating. So these things are going to repeat, and so the period of this particular function is pi by 2. So I can rewrite my entire integral as 16 times integral from negative pi by 4 to pi by 4 a mod of sin x plus mod of cos x dx. Now we're going to make use of the properties of definite integrals. Well, this is an even function, so I can rewrite this as 32 times integral from 0 to pi by 4 mod sin x. Well, mod sin x in 0 to pi by 4 is going to be just sin x, and cos x in 0 to pi by 4 is also going to be just cos x. Well, this is a very simple integral to evaluate. So you have 32 times negative of cos x plus sine x evaluated between 0 and pi by 4. So at pi by 4, what happens to cos x? Well, cos x takes the value of 1 by root 2. So you have minus 1 by root 2 plus sine x is going to be 1 by root 2 minus of, well, at 0, cos 0 is 1. So you have minus 1 plus sine 0 is 1, 0. So this is going to just cancel out and you will be left with an answer of 32. So again, whatever is given an option D is also false. So options A and B were the correct answers to this question. C and D were both false. So those very lucky students who would have marked options A and B and then thought, okay, I'm done, I don't want to solve any more of these integrals, would have actually got all the answers correct. But that is not a chance that those students who are aiming to get full marks in a question are supposed to take. It was just luck that options A and B were correct in this particular question. That may not be the case always. In this particular question, we've been given the function definition of f and g. F has been told to be equal to 2 minus mod of x when mod x is less than or equal to 1 and 0 otherwise. And g of x is equal to f of x plus 1. The objective in this particular question is to find out the integral from -3 to 3 of g of x dx. First of all, let's try and find out a proper function definition for g, because g is in terms of f. So let's write the definition for g. So my g of x is going to be equal to f of x plus 1, which is nothing but 2 minus mod of x plus 1 when mod of x plus 1 is going to be less than or equal to 1. So when mod of x plus 1 is less than or equal to 1, this means that x plus 1 is going to lie between -1 and +1. So you have -1 less than or equal to x plus 1 less than or equal to 1, which means that your x is going to lie between a -2 and 0. So g of x is going to be equal to 0 when x is less than -2 and x is greater than 0. So this is the function definition of g of x. Now I need to find out the integral from -3 to 3 of g of x. So I can rewrite this integral as integral from -2 to -3 to -2 g of x dx plus integral from -2 to 0 g of x dx plus integral from 0 to 3 g of x dx. Correct? And what happens is the first and the third integral, these will go to 0 because g of x is 0 in that particular subdomain. So finally, I just have integral -2 to 0 g of x dx. Now that's going to be equal to integral from -2 to 0 of 2 minus mod of x plus 1 dx. That's going to be simplified as integral from -2 to 0 2 dx minus integral from -2 to 0 mod of x plus 1 dx. Well, integral from -2 to 0 2 dx, that's going to be 2x between -2 and 0. That's going to give you an answer of 4. And what happens to mod of x plus 1, the integral of that, because there's a mod, and this mod of x plus 1 is going to change its nature at the point -1. X plus 1 is negative till -1 and x plus 1 is positive since then. So basically your mod of x plus 1, that's going to change the nature of its slope at point x equal to 1. So we are going to x equal to -1. So we are going to basically split that integral further as -2 to -1. Well, in -2 to -1, x plus 1 is going to be negative. So mod of x plus 1 is going to be minus of that. So that's going to be a plus of x plus 1 dx. With the minus of integral from -1 to 0, well, here it's going to be just x plus 1 dx. So now this is just very routine integration question, pretty straightforward and simple. That's going to be equal to 4 plus of, well, you had to integrate x plus 1. That's going to give you x square by 2 plus x. That's going to be evaluated between -2 and -1. A minus of, well, you have x square by 2 plus x, which is evaluated between -1 and 0. Very straightforward and simple. So you get 4 plus, well, when you put in the value of minus 1, you're going to get 1 by 2 minus 1 minus of, well, you have 4 by 2 minus 2. Well, 4 by 2 minus 2, that's actually equal to 0. So that's a simplification already. Minus of, when you actually put 0, you have zeros. So you're going to consider only the second part, which is going to be with a minus. So that becomes a plus outside. So you have 1 by 2 minus 1. So you have two 1 by 2 minus 1s. 1 by 2 minus 1 is actually equal to negative half. So the answer to this question is 4 minus half, which is nothing but 3. So the correct answer to this integer type of question is equal to 3. This question was not a difficult question. It was a straightforward, simple question. So this was actually high on arithmetic. So that's the deal with IIT advanced questions. If the questions are very difficult, then the arithmetic involved will be very easy, because most of your time will go into identifying the clue to solve the question and then solving the question. But if the question itself is easy, like this particular question is a very easy question, then the arithmetic is going to be intense, because then you have to spend a lot of time into getting the arithmetic correct. I always prefer the first type of question, which are challenging concept wise and not arithmetic wise, because if it's challenging arithmetic wise, then the chances of going wrong are much more than the chances of going wrong in a conceptually challenging question. So definite integrals is the single most important chapter of the entire 11th and 12th standard syllabus for the IIT JEE advanced examination. Number of questions come always from this particular chapter. So make sure that you are very thorough with the concept in this particular chapter. We've not completed the discussion of definite integrals. All those questions from definite integrals which can be solved using the concept of area under the curve, that's going to be solved in the next particular session of definite integrals. So be tuned to our channel, subscribe to our channel if you have not subscribed yet, because every time we make a video, you will be notified about it. And definitely when the next video on definite integrals come, you will be wanting to watch that particular video as well. So till I come up with yet another video, have a very great time preparing for your advanced examination, and I will see you very soon with yet another video.
For more videos and live lectures on the JEE, click on the subscribe button now.